Okay, a very good day to everyone. So I'm Dr. Liu Junten. So today I'm going to talk a little bit about how do we set up the LoRa WAN with online integration and compute platform. So this will be a LoRa learning module. So I'm teaching this from University Putra Malaysia. So without further ado, let us look into what is it about for this LoRa learning module. So this is a brief introduction on how are we going to do the setup. So from the slide, you can see is this overall connection for our LoRa WAN setup. So we have this LoRa device that will do the data acquisition. And then we have the data forwarder, which is the gateway over the cellular network LTE. And then all this data will be collected at the cloud LoRa WAN server, and then from this cloud, we will do an online integration and compute platform using Pipe and then store all the data collected from this LoRa server, LoRa network into the Google Sheet. So that is what we're going to learn today using a very brief example. So this is actually a LoRa air pollution block diagram, which is the example we'll be using, because what we did here is that we set up a LoRa network and then using a LoRa air pollution sensor. So all these sensors are attached to a LoRa node, and then this LoRa node, after collect all the data, will send it to the LoRa server. So this is just a brief introduction or brief illustration to show you how does the block diagram or the LoRa node look like. This is the LoRa transmission module, and then we have this powered by solar energy, and then we have connected ozone sensor, dust sensor, and monoxide gas sensor to it. But in this example, because what we are trying to focus here is how do we set up the connection. So we will not go too much into what are we going to use about the sensor. We're just going to try to send a hello world message over the LoRa communication node to the server, and finally store it in the Google Sheet. So next, this is a brief content on our slide today. So on the first half of this slide, I will try to guide you through what is going on using this slide. But in the second half of it, to make it easier for you to understanding or easier to follow, I have basically asked my student to record a video on it, and then I will try to explain on what he is doing in the video to guide you through step by steps from how are we going to do the joining to the LoRaWAN server, and then packet conversion to string, configuration of pipe dream, linking the database to the LoRaWAN server, and finally, how are we going to test and validate if the data collected has been sent successfully to the cloud and finally stored in the Google Sheet. So in this slide, you can see that basically in UPM, we have two types of LoRaWAN gateway. One is the outdoor gateway, which is installed at the top of our engineering tower. And then another one is the indoor gateway. So both of them are using to collect all the data collected from the end node or the end terminal. So as you can see from the photo. And then in order to do the setup and configuration, what you need is basically you need the gateway, and then you need a PC, be it running in Windows or Mac OS, and then on the right here you can see is actually a LoRa or 6-watt discovery kit with a micro USB cable. So that's on the hardware side. On the software side, you'll need to download the Arduino IDE and the STM32 ST-Link utility, which you can download using the link provided in the slide. So this slide will be uploaded to the learning platform, so you can access it and then use it to download to get all the links and refer to these materials whenever you feel like it. Okay. So first thing first is how we do the Arduino board setup. So to do the Arduino board setup, you will have to use the Arduino IDE, and then from there go into the preference, add this link into it, and then open the board manager from the tools board menu, and then install the Telecrop STM32LO boards, and then select the STM32LO board from the tools in the board menu. So you can see this is some of the screenshot on how you can install it to install the driver. And then you have to program the board in order to set the communication frequency, because LoRa transmission is transferred wirelessly. So it is very important. You have to set the transmission frequency in order to avoid collision, especially if you are setting up a LoRa network with a lot of end nodes. So you have to be very careful about it. So you can see all you need to do is just select or open the Arduino software, and then you have to change it, as you can see from the screenshot. Okay, so it is quite easy and very straightforward to do. And then next is the key part of our learning module here. So the key part here is how do we actually, when we already have a LoRa node, how do we actually get it to join the LoRa WAN server? So starting from this part, I will run the video, and then we will watch the video together while I point out what exactly he's trying to do here, and then what are we trying to achieve, and explain it for you throughout the way. So this video overall lasts about 20 minutes. So we will start from joining the LoRa node, and then configuring the pipetrain all the way until we're done with the testing and validation. Okay, now so from this video, we'll look at how can we actually get the device EUI. So the device EUI is basically a device unique ID that allow us to identify the device that we need to connect to our LoRa gateway. So it is important for us to know that. So it is basically set. It is basically set by the manufacturer. So every LoRa node has its own unique EUI. So on the video now, we can see that it's basically a code that allow us to identify what is the ID of the specific LoRa node. So what we have to do is that we just have to run this code, open it, run it, and then we can check for our device EUI in the serial monitor, as you can see from the video here. So you can see that after it run the file, and then open up the serial monitor, and then you can see that the device EUI is basically shown on the screen. So this number is very important. So all you need is that you just have to copy this number, and then later on save it somewhere. Later on, when you try to establish the connection between your gateway and this LoRa node, you have to use it or paste it somewhere or fill it up in the settings. So that's basically what we have to do here. So get the device EUI, save it somewhere, and then keep it, and later on you have to use it. So that is what actually going on in this video here. So the important part is run this code and then use the serial monitor to get what we want here. Okay, so in the previous video, we already show you how to acquire the device EUI. So in this video, we're going to continue the content of our LoRa module, which is establish the connection between the LoRa node and gateway, and also on how to configure the middleware, which is Pipe in our case, and then finally store the data, test and validate it. So let us continue to see how can we do that. So okay, the next step to do it is actually to join the device to the gateway. So after actually when we install the IDE, we already get the code, so we actually don't have to write the code here on joining the device to the gateway. So as you can see from this video here, we can basically select the code from the LoRaWAN, and then to the LoRaWAN join ABD, and another one is join OTAA. So there are two methods here, but the only method that we're going to look into in this tutorial is basically we're going to look into the OTAA. So OTAA basically it stands for over the A activation. We choose it because it is actually more secure. So that's is what we are going to use. So after click it, so you'll see this code here. So once we already get the EUI just now, so we will add it here, and then the app key is something that we can set later on, and then the app key has to be 32. But also you have to remember that it is key for us to set the app key the same for both the application and the LoRa devices here. So you can see that, okay, let's go back a little bit. So we have to create a new application. So application here means basically what are you going to do with your, what are you going to do with your LoRa network here. So basically because we want, this is just for a tutorial purpose, so we just put it as TOT here, as you can see. And then this LoRa server here is basically provided by our vendor in UPM. So we can basically access it and then to choose to open it and then to do the configuration here. Okay, so the name here, basically you can just choose anything you want, and then after you name it, and then the description, same, you can just make something that is easy for you to know what you're doing. Now make sure that it is easily understandable, and then you have to choose the profile. So for the profile here, make sure that you set it to LoRaWAN SP, okay? And then after that, just click create application. So okay, so 62 or the TOT application is what we are using now, and then we have to now link the device to this application. So the device name again is something that you can name to make it easier for you to remember, and then the description, and then finally is the device EUI. So the device EUI basically is the device EUI that we have recorded just now. So make sure you copy and paste it here, and then the profile, choose LoRaWAN DP, and then create device. So in this video, because we already tested it out, so the device basically has been created. That's why you see the pop-up says the device already exists. So, but the process is the same. Just click create device, and then we can proceed. Yeah. So basically here, what you can see is that because the students already created the application and link it with another application. So instead of using the application that he just show how to create, Now he go back to another application with the linked devices. Okay, so basically what you see here is that it click on the application that he has created before, and then it click on the devices. So the device here, basically the NASA test, is the device that he ran the get device EUI code just now. So this is basically the new device that we just create and connect to the gateway. So you just click on it, and then you can see the configuration is done exactly like what we have seen just now. And then click on the live device data so that we can see whether the node is actually transmitting. So right now there's nothing yet. So what we need to do is that we go back to the LoRa when join OTAA code just now. So inside this code, you can see what is the application EUI, the app key, the 632, as I mentioned just now, the device EUI that we get just now. So you can see all the details here, and then you just have to run the code. So because actually you can see on the bottom part of the code, you can see what is the operation. So the operation here is that we ask the node to begin to send the data here, which is a hello world. So it will send the data and then print packet send. Okay, so this is basically the process. So if the transmission is successful, basically the gateway will receive the hello world from this device. Okay, so you can see now the code is basically running. So it is transmitting now. So the code, not the code, the packet has been uploaded. So go back here to see whether we have data. So you can see we can see two things here. First is the join request. So the join request, after successfully joined, you can see the uplink. So the uplink is basically the packet transmitted from the LoRa node to the gateway here. So basically, the uplink, this message is a complete message here. So the complete message here, so you can see a lot of things. So you will see once again stated the application ID, what is the application name in this case, which is the NASA test, and then the data. The data is basically a code. So because it is actually encoded, so you will not see hello world now. So the SGVS blah blah blah, it's basically hello world, which is what we try to transmit just now. And then the device name and so on. So you get a full package of information from the device actually. So you can see that we have multiple packets coming. So because it is basically repeating. So again, you can see that the code says is send hello world. And then in order to make sure, how do we make sure that the data we receive is actually hello world? So it's very easy. All you need to do is just copy the data just now, and then use any website decoder you can find online, and then decode it. Basically, you can see what it is. So from this video, you can see that after we paste the data onto the website, you can see when we press decode, we can see what we get is basically hello world, which is what we intend for the node to send just now. So basically, it means that at least the transmission from the node to the gateways is actually successful here. And then at the moment we are setting the transmission with a delay of 10 seconds here. So you can see that basically what the students typing now is to set the timing. So the delay bracket Just now it's 10,000 because the unit of it is actually in millisecond. So 10,000 millisecond is 1,000 millisecond is 10 if I'm not mistaken. So oh no, yeah. So the delay is basically set based on what you would actually need. So when you only have one node, it's easy. So you can just set anything, there will be no collision. But if you have multiple nodes connect to the same gateway, then you might have to reconsider it because you have to make sure that the transmission from the node to the gateway is not collided. So you can basically do it like a random, or you want to like schedule a specific timing for them. So that's up to how the researcher or the network operator want to do it. So you can do it however you like here. So you just have to focus on tweaking the delay on the code just now, on the join OTAA just now. Yep. So you can see that basically the packet is still keep coming in at approximately 10 seconds, and because there are some delay at times, so you can see that the interval is not exactly 10 seconds all the time as well. So okay, so basically that's on how we join the LoRa device to the gateway. And then next, we're gonna use pipe dream. We are going to set up the middleware between the cloud or the LoRa gateway, LoRa server to the Google Sheet on how do we store the data received here. So okay, so actually beside pipe dreams, there are a lot of middleware website or you can use to do this, but pipe dream, we're using pipe dream here because it is relatively easy. So okay, so what you need to do is that when you go into pipe dream, you have to create a new one to yourself, and then you have to do the configuration again. So in the LoRa server, what you need to do is that after you finish configure the connection, set up the connection, the transmission between the device and the gateway, next you have to do the integration. So integration is what allows you to connect this LoRa server to the middleware and finally to the Google Sheet. Yeah, so this is how the integration page look like. So just click on your application, click on the integration, and then choose the HTTP. So on the pipe dream here, just click new, choose the HTTP API. Okay, click on it, and then you will get a unique link here. So this unique link is what you need. Just copy it, and then back to the integration part, create, and then choose the kind of integration that you will need to use here. So okay, so because we're using the HTTP API, so just choose the HTTP integration, and then paste the link that you have copied just now. And then just click create the integration. And then again, because we already created firsthand to test it and to test it out, so it's already exists here. Okay, so click on it. Click on the one so the student basically did what he did is that he clicked on the application that he already created. So on the left side here, on the left plane here, you can actually see the stream of data coming in from the LoRa server here. So you can see the timestamp, and so you can just click on it to make sure to see the transmissions going, to make sure that the pipe dream has actually received the stream of data as well. So okay, so you can see that basically just click on click on any one of them. So this is what you'll see. You can see similar to what we have seen on the live data on the LoRa server just now. You can see everything, the whole message from the LoRa device on the application ID, the body, and so on. So here, so what we have did actually is that we have connect the LoRa server, and then with the middleware using integration. The middleware is the pipe dream. So we have one server, the middleware. Now we have to set up the Google Sheet as a means of storage. So that's what we're doing now. Yeah, so just click on it. So there are a lot of there are a few options here, but some of them you have to pay for it. So so in this tutorial, we're just gonna show you the one that is free, which is add a single row to the sheet. So after you click on it, and then it will show a new section. So in this new section, basically, there are a few things that you need to do, because Google Sheet ties to your Google account. So if you didn't sign in your Google account before, you have to sign it in first. But in this case, the student has already signed in his Google account, so you just have to click it from the drop-down menu, and then select that one. Okay, so in this, after you have select that, because the website is receiving everything, the whole message from the node, so you have to specifically tell pipe dream on which column or which parameters that you want to save or store in the Google Sheet. So that's basically what we have to do now. So you can see that there's a few here: data, device UI, device name. So this is actually very useful here, because that means that in this example, we're only doing sending one message, which is hello world. So you only have to save one parameters here. But if you are doing if your LoRa device is connected to multiple sensors, so you have multiple parameters or attributes coming in, so you have to select it carefully to make sure that you save what you want to save here. Okay, so this is how it looks when you click it, and then after you click it, you can pick which part of the message that you actually want to store here. So in this case, just click after the events. We have like body, header, and so on. So inside body and the data is what we want to store here. So we just have to click that. So the student, because just now we selected older entries from a while before. So what he did now is that he select latest entries, and then doing what exactly he have shown us just now. So log in the Google account, then select the parameters, in this case, which is event, body, and then data. And then, so that's the parameter that we want to store. But which spreadsheet are we going to store in? So just go to your Google account, create a spreadsheet, and then inside this spreadsheet, so the title, you can just name it anything you want, but the key is to get the unique ID from this Google spreadsheet here. So the ID of the Google spreadsheet here, basically you can find it in the URL. So you can see that what he's doing on the URL. The unique ID is basically whatever after the D slash all the way up until slash edit. So just copy that. Copy that and then just paste it in this field. And then okay, that's basically done it for the spreadsheet ID. And then you just have, excuse me, so you just have, now you have to select the sheet name. So we only have one sheet, so it's sheet 1. And then now it's good to go, just click deploy. Okay, now to see whether the data is actually transmitted, just click on the Google Sheet, and then you can see the data stream is actually coming in. So so from this Google Sheet, you can actually see that the stream of data is coming in, but it is still encoded data that has not been decoded, because remember just now what he showed earlier is that he decoded the data based on a decoder on a website. So we did not decode the data yet. So that's why what you can see is that it's a string that we can't even know what it is saying. So the same string as GVS and so on. That's stand for hello world here. So basically, up until this point, you have witnessed how to get the device EUI, connect the device to the gateway, and then use the LoRa server to create the application for it. And then from the application, do the integration using Pipedream. And then using Pipedream, connect to the Google Sheet, and then store all the data coming in from your LoRa network. So, so in the Google Sheet just now, what you have seen is that the data is basically unreadable because it is encoded. But for the LoRa server, basically, you are present with an option to run a custom JavaScript where you can do any fancy things with it. So that in this case, you might want to decode the data that is coming in. So this is where you write the JavaScript to do the things that you want. So in this video, he already written the code here. So in the application, so what he did is that just put a code there, and then after that run it, and voila, you'll get decoded data in the Google Sheet. So in this case, so at this moment, he didn't do the decode yet. So, but on the application, as I mentioned just now, there's an option for you to do so. So this is basically the code that he'll be using. And then So he can check again. So he checked again because before that he didn't the LoRa application did not run the JavaScript. So what he did just now is that he correct the code a little bit, and then after you do the correction or any amendments to it, and then make sure to update the application. So once you update it, click on the application again, and you can now check on the live device data after the JavaScript went live. So okay, so let's see in this code now. So you can see that now the data is still the same data, SGV and blah blah blah, but because of his JavaScript has specified on the code process, so on sensor 8 object, you can see we basically receive the hello world. So just disregard the sensor 8 because that's what he asked the code to do, asked the application to do, the JavaScript to do. So you can write it however you like. So again, now after you have updated the application with the JavaScript, because the parameters now we wish to save into the Google Sheet is different. So make sure that you have to change it as well. So go back to Pipedream and then change the parameters, because the parameters data is basically an encoded hello world. What we need is basically a decoded version of it. So make sure to change that. So select it in the event body, and then within object, I believe. Okay, object, and then sensor 8. And then that is the path. Just click it. And then deploy again. Make sure to deploy again, because similar to the application, after you make any amendments, make sure to update or deploy it again. So okay, now with the new updates to the Pipedream, now let's check the Google Sheet, and voila, you can see that now it is basically a decoded version of the message. So with hello world being saved in the Google Sheet. So basically that's it. So through this tutorial, I have shown you briefly on how do we set up a LoRaWAN network from the perspective of getting the EUI, joining it to the gateway, and then set up the middleware, and finally store the data in Google Sheet. And also a very brief on how do we check on the data stream and validate the storage on the Google Sheet. And that's it for me. Thank you very much.